In the frozen vacuum of space, 13 billion light-years from Earth, something impossible is staring back at us. The Jameswebb Space Telescope has peered deeper into the cosmic abyss than any instrument before it, and what it found defies every law of physics we thought we understood. Ancient galaxies that shouldn't exist, black holes older than time itself, and signals from rogue worlds screaming across the void. If you enjoy discovering the universe's darkest secrets, hit that like button, because what I'm about to show you will change how you see reality forever. Prepare yourselves. We begin. Something is terribly wrong with the universe itself. For decades, scientists believed they understood how fast our cosmos was expanding. The Hubble Space Telescope gave us one measurement. Mathematical models predicted another. Everything seemed to fit together like pieces of a cosmic puzzle. Then, James Webb looked deeper than anyone had ever looked before, and the puzzle exploded into 1,000 fragments. The universe is expanding at two completely different speeds depending on where you measure it. Think of it like a balloon being inflated, but the top half stretches twice as fast as the bottom half. This should be impossible. The laws of physics demand that expansion happens uniformly across all of space. Webb confirmed what astronomers feared most. When they measured the expansion rate using distant stars called Cepheid variables, they got one number. When they calculated it using the cosmic microwave background radiation, they got a completely different number. The difference isn't small. We're talking about a discrepancy so massive that it suggests our fundamental understanding of reality is wrong. Scientists call this the Hubble tension, but that name doesn't capture the true horror of what we're dealing with. This isn't just a measurement error or a calibration problem. After studying over 1,000 Cepheid stars across 5 separate galaxies, stretching 130 million light-years into space, the contradiction remains. The implications are staggering. Either our models of how the universe works are completely broken, or there's some unknown force tearing reality apart. Dark energy, the mysterious substance that drives cosmic expansion, might be behaving in ways we never imagined. Some regions of space could be expanding faster than others, creating cosmic rifts that challenge everything we know about spacetime. Adam Rees, the lead researcher who discovered this crisis, put it bluntly: with measurement errors ruled out, what remains is the real and exciting possibility that we have fundamentally misunderstood the universe. The word exciting feels wrong when you consider what this means. If our basic understanding of cosmic expansion is incorrect, then our calculations about the universe's age, size, and ultimate fate are all suspect. Webb's unprecedented precision has removed any doubt about the measurements. Both the telescope and Hubble are detecting the same impossible contradiction. The universe is expanding, but it's doing so in a way that breaks the laws of physics as we understand them. This discovery alone would be enough to shatter cosmology textbooks. But Webb was just getting started. As the telescope continued its survey of deep space, it began finding objects that shouldn't exist, behaviors that defy explanation, and phenomena that suggest our reality is far stranger and more dangerous than we ever imagined. The expansion crisis was only the beginning of a series of discoveries that would force scientists to question everything they thought they knew about the cosmos. But what Webb found next makes the expansion problem look simple by comparison. 6 impossible monsters are floating in the ancient cosmos, and they're rewriting the laws of galactic evolution. When James Webb pointed its infrared eyes toward a seemingly empty patch of sky near the Big Dipper, astronomers expected to find tiny baby galaxies stumbling through their first billion years of existence. Instead, they discovered 6 massive, mature star systems that shouldn't have had time to grow so large. These galactic giants contain nearly as many stars as our own Milky Way, but they formed when the universe was only 3% of its current age. Picture trying to grow a full-sized oak tree in just 3 months. That's essentially what these galaxies accomplished on a cosmic scale. Star formation takes time, Gravity needs millions of years to pull together enough gas and dust to ignite nuclear fusion. Yet these 6 systems somehow fast-tracked their development, becoming galactic titans while the universe was still in its cosmic infancy. The discovery happened almost by accident. Astrophysicist Erica Nelson was examining postage stamp-sized sections of Webb's deep field images when she spotted several fuzzy red dots that looked impossibly bright. Red light in astronomy usually means old light, stretched by the universe's expansion during its long journey to Earth. But these objects were both ancient and blindingly luminous, a combination that defied explanation. Each of these monster galaxies contains between 10 billion and 100 billion stars. To reach such enormous sizes so quickly, they would have needed to form hundreds of new stars every single year for hundreds of millions of years. Our Milky Way, by comparison, creates only about 2 new stars annually. These ancient systems were stellar factories operating at production rates that modern physics says should be impossible. The team has informally nicknamed these objects universe breakers because they threaten to break our understanding of how cosmic structures form. According to every simulation and model scientists have created, matter in the early universe should have clumped together slowly and methodically. Small structures would gradually merge to form larger ones over billions of years. These 6 galaxies throw that entire timeline out the window. They suggest that the early universe was capable of organization and complexity that cosmologists never imagined possible. Either there's a completely unknown mechanism for rapid galaxy formation, or our fundamental assumptions about cosmic evolution are catastrophically wrong. The discovery raises terrifying questions about dark matter's role in early cosmic development. If galaxies could grow this massive this quickly, it means dark matter was clumping together and pulling in regular matter at rates far exceeding current predictions. The invisible scaffolding that shapes our universe might be far more violent and unpredictable than we realized. Joel Leha, one of the astronomers studying these objects, captured the magnitude of the problem perfectly. We looked into the very early universe for the first time and discovered something so unexpected that it creates genuine problems for science. But confirming whether these are real galaxies will require additional observations with Webb's spectrograph. And what those follow-up studies revealed would prove even more disturbing than anyone anticipated. A monster with the mass of 50 million suns is wandering through space completely alone, and it's rewriting the history of the cosmos. Deep in the early universe, Jameswebb discovered something that shouldn't exist according to every theory of black hole formation. Q-Soon is a supermassive black hole with virtually no galaxy surrounding it. It's essentially naked, drifting through space without the typical host of billions of stars that normally accompany such massive objects. Most supermassive black holes sit at the centers of galaxies like cosmic anchors, surrounded by spinning disks of stars, gas, and dust. They form a symbiotic relationship with their galactic hosts, growing together over billions of years through a delicate dance of gravity and star formation. Q-Soon breaks all those rules. This cosmic wanderer contains enough mass to equal 50 million of our suns, compressed into a region smaller than our solar system. To put that in perspective, if Earth were the size of a marble, QSON would still be invisible to the naked eye while containing more matter than exists in hundreds of billions of normal stars. What makes this discovery truly disturbing is the timing. QSON exists in the universe's childhood, just 600 million years after the Big Bang. Traditional black hole formation requires the death of massive stars, which means waiting for the first generation of stars to form, live their lives, and explode in spectacular supernovas. That process should take far longer than 600 million years. Roberto Maiolino, the Cambridge astrophysicist who helped identify QSON, described the find as completely off the scale. The object challenges every model scientists have created for how supermassive black holes grow and evolve in the early universe. 3 theories attempt to explain QSON's existence, and each one is more unsettling than the last. The first suggests that some black holes form directly from the collapse of massive gas clouds, bypassing the stellar phase entirely. The second proposes that intermediate mass black holes somehow grew at impossible rates by consuming matter faster than physics should allow. The third theory is the most disturbing of all. QSON might be a primordial black hole created in the universe's first seconds during violent fluctuations in space and time immediately after the Big Bang. If true, it means QSON has been lurking in the cosmic darkness since the very beginning, waiting 13 billion years for stars and galaxies to form and illuminate its presence. QSON is one of hundreds of similar objects that Webb has identified. These little red dots appear throughout the early universe, each one a potential cosmic monster that defies explanation. They glow with the light of matter being shredded and superheated as it spirals into their gravitational maws. The existence of these naked black holes suggests that the early universe was far more chaotic and violent than cosmologists ever imagined. Instead of the gradual, orderly formation of cosmic structures, we might be looking at evidence of primordial catastrophes that forged massive black holes before the first stars even existed. If QSON really is a primordial black hole, it represents something far more ancient and alien than any galaxy or star. But QSON wasn't the only impossible black hole that Webb would discover lurking in the cosmic deep. Black holes older than the first stars are lighting up the universe, and they might have been there since the moment of creation. Scientists have long assumed that supermassive black holes formed after the first generation of massive stars collapsed in spectacular deaths. This process should take hundreds of millions of years, as gravity slowly pulls together enough matter to ignite nuclear fusion. Stars live their brief but brilliant lives and then explode in supernovas that leave behind stellar corpses. But Jameswebb has found evidence of supermassive black holes existing when the universe was barely 400 million years old, far too early for this traditional formation process to work. Andrea Ferrara and his team at the Superior Normal School in Pisa, Italy, propose a radical solution to this cosmic puzzle. What if black holes, not stars, were the first significant sources of light in the universe? What if primordial black holes, formed in the chaotic first seconds after the Big Bang, were already lurking in the darkness when the cosmos was still in its infancy? These hypothetical primordial black holes would have formed through a completely different mechanism than stellar black holes. Instead of collapsing stars, they emerged from extreme density fluctuations in the primordial soup that existed less than 5 seconds after the Big Bang. Picture the early universe as a violently boiling pot of energy and matter, with some regions becoming so dense that they collapse directly into black holes without ever forming stars. The evidence Webb has gathered supports this bizarre scenario. Many of the bright objects in the early universe appear point-like rather than extended, suggesting they're powered by compact sources rather than distributed star formation. When gas gets near a black hole, it heats to scorching temperatures and emits brilliant light. From a distance, this superheated matter can appear almost identical to the light from stars. If this theory is correct, it means primordial black holes were feeding on the universe's first gas clouds, growing larger and more massive while simultaneously lighting up the cosmos. These monsters would have been sitting in the dark for hundreds of millions of years, essentially waiting for the universe to evolve enough to provide them with food. The implications are staggering. Primordial black holes could explain how supermassive black holes grew so massive so quickly in the early universe. They had a head start of hundreds of millions of years, allowing them to reach enormous sizes before the first galaxies even began to form around them. But this scenario raises even more disturbing questions. If primordial black holes were common in the early universe, they might still be out there today, invisible and undetected. Some could be wandering through our own galaxy, ancient relics from the universe's violent birth that predate every star we can see. These primordial monsters represent a fundamental shift in our understanding of cosmic evolution. Instead of a universe that gradually built complexity from simple beginnings, we might be looking at a cosmos that was born with powerful, massive objects already embedded in its structure. The detection of primordial black holes would also provide crucial insights into the physics of the Big Bang itself, revealing conditions in the universe's first moments that we can barely imagine. But Webb's surveys of these ancient black holes revealed an even stranger phenomenon that challenges our understanding of gravity itself. Two galaxies are crashing together in a cosmic train wreck that's creating physics we've never seen before. When astronomers first spotted the object, they nicknamed the Infinity Galaxy. Its shape immediately caught their attention. This cosmic oddity displays two compact red nuclei, each surrounded by glowing rings, creating a perfect figure-8 pattern that resembles the mathematical symbol for infinity. But the galaxy's unusual appearance was just the beginning of its mysteries. The Infinity Galaxy formed when two massive disk galaxies collided head-on in a cosmic crash that began millions of years ago. Galaxy collisions aren't unusual in the universe, but this particular smash-up has created something unprecedented. Instead of the typical chaotic merger that destroys both original structures, these two galaxies have maintained their individual identities while creating something entirely new. What makes this collision truly bizarre is the location of the supermassive black hole. In normal galaxy mergers, the central black holes from both galaxies eventually spiral toward each other, either merging into a single massive object or ejecting one from the system entirely. The Infinity Galaxy breaks this pattern completely. The supermassive black hole sits directly between the two galactic nuclei, suspended in a vast expanse of glowing hydrogen gas that's been stripped away from both galaxies during their collision. This positioning should be gravitationally unstable. The black hole should be pulled toward one nucleus or the other, not floating in the middle, like a cosmic referee overseeing the galactic crash. Pieter van Dokkum and Gabriel Brammer, the astronomers who discovered this system, believe they're witnessing something called direct collapse black hole formation. Instead of forming from the death of massive stars, this black hole might have formed directly from the collapse of a massive gas cloud created during the galaxy collision. The process works like this. When the two galaxies crashed together, they created enormous streams of gas flowing between their cores. Under exactly the right conditions, these gas streams can become so massive and dense that they collapse directly into a black hole without ever forming stars. It's like watching a cosmic avalanche that's so powerful it creates its own gravitational trap. This direct collapse mechanism could explain one of the most puzzling discoveries Webb has made in the early universe. The telescope has found supermassive black holes that are far too massive for their age, growing to enormous sizes faster than traditional formation models allow. If black holes can form directly from collapsing gas clouds, they could reach supermassive status much more quickly than previously thought possible. The Infinity Galaxy represents a real-time laboratory for studying this exotic formation process. The black hole appears to be actively feeding on the gas flowing between the two galactic cores, growing larger as the collision continues. Radio observations show intense energy emissions from exactly where the black hole should be located, confirming that it's actively consuming matter. But the most disturbing aspect of the Infinity Galaxy collision isn't what we can see happening now. It's what this discovery suggests about the violent processes that shaped the early universe. If direct collapse black hole formation was common during the cosmos's youth, it means the universe went through a phase of incredible violence and chaos that we're only beginning to understand. And that violence left behind objects even stranger than wandering black holes. Hundreds of orphaned worlds are drifting through space in pairs, and they're broadcasting radio signals that shouldn't exist. Jameswebb has identified over 500 free-floating planets in the Orion Nebula that don't orbit any star. These cosmic wanderers each roughly the size of Jupiter, have been ejected from their original solar systems and now drift through the cold emptiness of interstellar space. What makes them truly bizarre is that many of them travel in pairs, orbiting each other at distances ranging from 25 to 400 times the distance between Earth and the Sunday. Scientists call these paired wanderers Jupiter Mass Binary Objects, or JWMBOs. They challenge every theory of planet formation we've developed. Planets typically form in the disks of gas and dust surrounding young stars, slowly accumulating material until they reach their final size. The gravitational dance required to create binary planets should be incredibly rare. Yet, Webb has found dozens of these cosmic couples. The mystery deepened when astronomers pointed radio telescopes at these paired planets and discovered something unprecedented. Several gumbos are emitting radio signals with patterns never seen from planets before. These aren't the typical emissions you'd expect from worlds with magnetic fields interacting with charged particles. They're producing gigahertz frequency radio bursts thousands of times higher pitched than FM radio signals. On Earth, radio signals at these frequencies come from technological sources or extremely energetic astronomical phenomena like pulsars and quasars. Finding them coming from rogue planets suggests these worlds are experiencing physical processes that don't exist anywhere else in our solar system. The radio emissions appear to be linked to the binary nature of these planets. When two massive objects orbit each other, they create complex gravitational interactions that can generate powerful magnetic fields and electrical currents. Think of it like cosmic friction on a scale we've never encountered before. The jumbos are essentially giant electrical generators, powered by their orbital dance, but the signals themselves remain deeply puzzling. Different pairs of JWMOs produce different radio signatures, suggesting that each binary system has its own unique electromagnetic personality. Some emit steady streams of radio waves, while others produce sporadic bursts that follow no apparent pattern. The implications are unsettling. If these orphaned worlds can generate radio signals this powerful, what else might they be capable of? Their magnetic fields could be orders of magnitude stronger than anything we see in our solar system, creating space weather phenomena that could affect nearby star systems. Even more disturbing is what the existence of so many jumbos suggests about planetary system formation. If hundreds of these paired worlds exist in just one nebula, there could be millions or billions of them scattered throughout our galaxy. Each represents a failed solar system, a cosmic tragedy where gravitational interactions went wrong and ejected planets into the eternal night. These rogue worlds are cosmic orphans, forever separated from the warmth and energy of stellar companionship. They exist in perpetual darkness, their only source of heat coming from the slow decay of radioactive elements in their cores and the tidal forces generated by their orbital dance with their companion. But as disturbing as these wandering planets are, Webb discovered worlds that challenge our understanding of planetary formation in even more fundamental ways. The next discovery would force scientists to reconsider everything they thought they knew about how planets form around young stars. A young star system is defying the basic rules of planet formation by creating worlds made of the wrong materials. In the star-forming region, known as NGC 6357, Jameswebb discovered a planet-forming disk that contains almost no water but is rich in carbon dioxide, exactly where Earth-like planets should be forming. This finding shatters one of the most fundamental assumptions about how rocky planets develop around young stars. Every model of planetary formation assumes that the regions around young stars where rocky planets form should be dominated by water, ice, and silicate minerals. Water is one of the most abundant molecules in the universe, and its presence in planetary disks is considered essential for creating the kinds of worlds that could potentially support life. The disk around the star, XUE, 10 throws all of these assumptions into chaos. When Webb examined this system using its near-infrared spectrograph, astronomers expected to see the familiar signature of water vapor mixed with other common compounds. Instead, they found a disk where carbon dioxide dominates the inner regions, where terrestrial planets typically form. Water is so scarce that it's barely detectable, creating an environment unlike anything scientists have modeled before. This discovery challenges everything we understand about planetary formation chemistry. On Earth, water played a crucial role in creating our planet's geology, atmosphere, and ultimately, the conditions that allowed life to emerge. A planet forming in the XUE-10 system would develop under completely different chemical conditions, potentially creating types of worlds that have no analog in our solar system. Two theories attempt to explain this bizarre chemistry, and both have unsettling implications. The first suggests that intense ultraviolet radiation from either the young star itself or from massive nearby stars has essentially sterilized the disk, breaking apart water molecules and driving the hydrogen away while leaving oxygen to combine with carbon. The second theory is even more disturbing. The carbon dioxide dominance might result from unusual conditions in the dust grains that make up the planetary disk. Instead of being coated with water ice like dust grains in normal systems, these particles might be covered with carbon dioxide due to the specific environmental conditions around this young star. Either explanation suggests that planetary formation can follow pathways that astronomers never imagined. If ultraviolet radiation can strip water from planet-forming disks, it means that many potentially habitable worlds might never get the chemical building blocks they need to support life. The galaxy could be filled with dry, carbon dioxide-rich planets that formed under conditions hostile to the chemistry we associate with life. This discovery also raises questions about the diversity of planetary systems throughout the galaxy. If planet formation can produce such dramatically different chemical environments, there might be entire classes of worlds out there that operate according to geological and atmospheric processes we've never encountered. The XUE-10 system represents a natural laboratory for studying alternative planetary formation pathways. As the planets in this system continue to develop, they'll provide insights into how worlds form when the basic chemical ingredients are fundamentally different from what we see in our own solar system. But the strange chemistry of planet formation was just one of many atmospheric mysteries that Webb would uncover. The telescope's next target would reveal a world so hostile and alien that it challenges our definition of what constitutes a planetary atmosphere. A world so close to its star that its surface glows like molten metal somehow maintains an atmosphere that defies every law of planetary science. 55. Cancri E orbits its star so closely that it completes a full year in just 18 Earth hours. This hell planet is tidally locked, meaning the same side always faces its star, creating a day side hot enough to melt copper and a night side plunged into eternal darkness. Surface temperatures reach over 4,000 degrees Fahrenheit, hot enough to vaporize most known materials. By every rule of planetary physics, this world should have lost its atmosphere billions of years ago. Jameswebb discovered something impossible. This hell planet not only has an atmosphere, but it's composed of materials that shouldn't be able to exist as gases at such extreme temperatures. The atmosphere appears to be rich in carbon monoxide and carbon dioxide, creating a thick blanket around a world that should be as airless as Mercury. The discovery came through careful temperature measurements using Webb's mid-infrared instrument. When astronomers measured the thermal emissions from the planet's day side, they found it was cooler than expected. Something was blocking and redistributing the star's heat, and that something could only be an atmosphere thick enough to transport energy from the scorching day side to the frozen night side. This atmospheric circulation creates one of the most extreme weather systems ever discovered. Imagine winds howling at thousands of miles per hour, carrying vaporized rock and metal from the day side to the night side, where these materials condense and fall as rain made of molten minerals. The temperature difference between day and night sides should be over 3,000 degrees, but the atmosphere somehow moderates this difference through convection currents that operate under conditions no Earth-based laboratory could replicate. What makes this atmosphere truly impossible is its source. The Hell planet's atmosphere can't be a remnant from its formation, because solar winds from its nearby star would have stripped away any primordial gases within millions of years. Instead, researchers believe this is a secondary atmosphere, continuously bubbling up from the planet's interior. Picture a world where the crust itself is boiling. The intense heat and tidal forces from the nearby star are literally cooking the planet's interior, causing carbon-rich materials deep underground to vaporize and escape through volcanic outgassing. The atmosphere is constantly being destroyed by stellar radiation and constantly being replenished by geological processes operating at temperatures that would vaporize most known materials. This creates a hellish cycle where the planet's own interior feeds its impossible atmosphere. Rock vapor rises from the surface, gets blown around the planet by supersonic winds, condenses on the night side, and rains back down as liquid metal and stone. The entire world has become a massive distillation apparatus, operating under conditions that push the boundaries of what physics allows. The existence of 55 Cancri-E's atmosphere suggests that planets can maintain gases under far more extreme conditions than scientists previously thought possible. This has profound implications for our understanding of potentially habitable worlds. If atmospheres can survive in such hellish environments, they might also persist around planets that we've written off as too hostile for any kind of atmospheric chemistry. But the Hell planet's impossible atmosphere was just a warm-up for Webb's next discovery. The telescope was about to encounter a visitor from another star system that would challenge our understanding of time itself. An ancient comet from another star system is racing through our solar system, and it's older than Earth, the Sun, and everything we call home. Comet 3I Atlas appears unremarkable at first glance. It's about 7 miles wide, composed of ice and rock, and follows a trajectory that will take it past our Sun before returning to the void between stars. But Jameswebb's detailed analysis revealed something that shouldn't be possible. This interstellar visitor is approximately 7 billion years old, making it 3 billion years older than our entire solar system. When astronomers tracked the comet's steep trajectory through space, they realized it came from the Milky Way's thick disk, a region of our galaxy filled with ancient stars that formed when the universe was much younger. This cosmic wanderer has been drifting through interstellar space since before the Sun was even a glimmer in a stellar nursery. It predates Earth, Mars, Jupiter, and every planet in our neighborhood. Webb's near-infrared spectrograph revealed that the comet's coma, the cloud of gas and dust surrounding its nucleus, is dominated by carbon dioxide rather than the water vapor typical of comets from our solar system. This unusual composition provides clues about the chemical environment of the star system where it formed billions of years ago. The comet is traveling at over 130,000 miles per hour, fast enough to cross the entire United States in less than 2 minutes. Its trajectory is unusually flat and straight, unlike anything else in our solar system. This interstellar intruder follows the gravitational rules of the galaxy rather than our Sun, treating our entire solar system as just another obstacle to navigate around. What makes this ancient visitor truly unsettling is what it represents. 3I Atlas is a messenger from a time when the universe was radically different from today. 7 billion years ago, the Milky Way was more chaotic and violent. Star formation rates were higher, heavy elements were scarcer, and the chemical processes that build planets operated under different conditions. This comet formed around a star that lived and died billions of years before our Sun existed. It survived the death of its parent star, possibly a violent supernova explosion that destroyed its original solar system and sent it wandering through the galaxy. For 3 billion years, it traveled through the cosmic deep, a frozen time capsule carrying chemical signatures from an ancient epoch. The fact that we're seeing it now raises disturbing questions about how many other ancient visitors might be passing through our solar system undetected. 3. I-Atlas is only the third confirmed interstellar object ever discovered, but statistical models suggest that dozens or hundreds of these cosmic time travelers should be crossing our neighborhood at any given moment. Each represents a fragment of a destroyed world, a piece of cosmic history that survived catastrophes we can barely imagine. They're archaeological artifacts from stellar systems that existed when the universe was young, carrying information about galactic conditions from epochs that no other objects can provide. But 3 I-Atlas also serves as a reminder of our solar system's ultimate fate. In a few billion years, when our sun begins to die, objects from our world might be ejected into interstellar space, becoming ancient wanderers that will puzzle astronomers in distant galaxies long after Earth is gone. The ancient comet's visit was a preview of cosmic timescales that dwarf human understanding, but Webb's surveys revealed objects even more mysterious than ancient visitors from dead star systems. 300 mysterious objects are glowing in the early universe, and astronomers can't figure out what they are. Jameswebb's deep surveys have uncovered a new population of cosmic objects that don't fit into any known category. These little red dots appear as tiny crimson pinpricks of light scattered throughout images of the early universe, but their properties are so unusual that scientists are struggling to classify them. Each one is far brighter than it should be, given what we know about galaxy and star formation in the universe's youth. The mystery begins with their color. In astronomy, red light usually indicates either great distance or cool temperatures. These objects are definitely distant, existing when the universe was less than 1 billion years old, but they're also incredibly luminous. They're producing enormous amounts of energy through unknown processes, creating a combination of properties that doesn't match any object in the modern universe. Using advanced techniques like infrared imaging and spectral energy distribution analysis, astronomers at the University of Missouri identified 300 of these enigmatic objects in Webb's data. Each one appears to be roughly the size of early galaxies, but produces far more light than galaxy formation models predict. If they're galaxies, they're unlike any that exist today. The objects are so bright that they force scientists to reconsider how galaxies could have formed in the early universe. Traditional models assume that the first galaxies grew slowly, accumulating matter through gravitational collapse over hundreds of millions of years. The little red dots suggest that some process was creating massive, luminous structures much more rapidly than current theories allow. But here's where the mystery deepens. When astronomers try to determine exactly what's producing all this light, the answers don't make sense. Some of the objects appear point-like, suggesting they might be powered by supermassive black holes rather than distributed star formation. Others show evidence of extended structure, indicating they might be genuine galaxies undergoing extraordinarily rapid star formation. The most disturbing possibility is that these objects represent a completely unknown phase of cosmic evolution. During the universe's first billion years, physical conditions were drastically different from today. Matter was denser, dark matter interactions were more frequent, and the cosmic web of large-scale structure was still forming. Perhaps these conditions allowed for types of object formation that can't happen in the modern universe. Some of the little red dots show evidence of extremely high energy processes. They emit X-rays, ultraviolet radiation, and infrared light in patterns that suggest violent, chaotic energy production. Whatever is powering these objects is operating under extreme conditions that push the boundaries of known physics. The objects also appear to be distributed randomly throughout space, rather than clustered in regions where early galaxy formation was expected to occur. This random distribution suggests they might represent a fundamental property of the early universe, rather than rare, isolated phenomena. Bangjeng Sun, the graduate student leading the research, emphasizes that even if only a few of these objects are confirmed to exist in the early universe, they will force scientists to modify existing theories of galaxy formation. The sheer number of mysterious objects Webb has found suggests that our understanding of cosmic evolution during the universe's youth is fundamentally incomplete. The little red dots represent perhaps the most significant challenge to cosmology that Webb has discovered, but their mystery pales in comparison to what the telescope found when it looked at the large-scale structure of the universe itself. Galaxies across vast regions of space are spinning in synchronized patterns that suggest the universe might have been born rotating. In what may be Jameswebb's most mind-bending discovery, astronomers have found evidence that galaxies separated by millions of light-years are rotating in coordinated patterns. This cosmic choreography defies our understanding of how structure forms in the universe and raises the possibility that the entire cosmos was born with a preferred direction of rotation. The discovery emerged from observations of 263 galaxies captured during Webb's Advanced Deep Extragalactic Survey. When astronomers analyzed the orientation and rotation patterns of these distant star systems, they found something that should be impossible according to standard cosmological models. Galaxies that are far too distant to have any gravitational influence on each other are spinning in similar directions. Think of it like discovering that every windmill across an entire continent is turning in exactly the same direction, even though there's no wind pattern that could coordinate their motion. The galaxies are separated by distances so vast that light from one would take millions of years to reach another. Yet they're all participating in the same cosmic dance. Leo Shamir, the computer scientist who led the analysis, identified two possible explanations for this phenomenon, and both are deeply unsettling. The first is that the universe was born rotating. If the Big Bang itself had angular momentum, it could have imprinted a preferred rotational direction on the cosmic structure that formed afterward. This explanation aligns with black hole cosmology, a theory suggesting that our entire observable universe might be the interior of a massive black hole within a larger parent universe. If true, the rotational patterns Webb observed could be evidence of the parent black hole's spin, transmitted across cosmic scales through mechanisms we don't understand. The second explanation is even more disturbing for conventional cosmology. If the universe wasn't born rotating, then the coordinated galaxy spins suggest that existing theories about cosmic evolution are fundamentally incomplete. Some unknown force or field must be operating on scales larger than anything scientists have previously considered. The implications extend far beyond galaxy formation. A rotating universe would have different physical properties than the static cosmos described by standard models. Space and time themselves might have preferred directions, creating asymmetries in physical laws that could affect everything from particle physics to the ultimate fate of the universe. The discovery also raises questions about dark energy, the mysterious force driving cosmic expansion. If the universe has a preferred rotational axis, dark energy's effects might vary depending on direction, creating a cosmos that expands faster in some directions than others. This could explain some of the anomalies Webb has found in cosmic expansion rates. Perhaps most unsettling is what a rotating universe suggests about our place in the cosmic hierarchy. If our universe is spinning inside a larger structure, it implies that reality extends far beyond the observable cosmos. We might be living inside just one component of an incomprehensibly vast multiverse where entire universes rotate like galaxies within some higher dimensional space. The coordinated galaxy rotations represent a fundamental challenge to our understanding of cosmic structure formation and the nature of space itself. But the universe's hidden rotations were just the beginning of Webb's assault on conventional physics. The telescope's next discovery would reveal black holes forming through processes that shouldn't be possible. A supermassive black hole is forming in real time through a process that breaks every rule of stellar evolution. Deep in the cosmos, James Webb discovered a galactic collision, creating something unprecedented. The system astronomers call the Infinity Galaxy hosts a supermassive black hole that appears to have formed through direct gravitational collapse rather than the death of massive stars. This process is unfolding in a location where no black hole should be able to exist. The black hole sits suspended in a vast expanse of glowing hydrogen gas between two colliding galactic nuclei. In normal galaxy mergers, supermassive black holes from each galaxy eventually spiral toward each other, creating binary systems that either merge or eject one black hole entirely. The Infinity Galaxy breaks this pattern by hosting a black hole in gravitational no man's land. Pieter van Dokkum and Gabriel Brammer discovered this system while examining Webb's deep field images. The galaxy's distinctive figure 8 shape immediately caught their attention, but follow-up observations revealed something far more significant. Radio emissions from the system pinpoint a massive black hole exactly where theory says it shouldn't be able to survive. The direct collapse process works like cosmic avalanche. When the two galaxies crashed together, they created enormous streams of gas flowing between their cores. Under exactly the right conditions, these gas streams became so massive and dense that they collapsed directly into a black hole without ever forming stars. It's gravitational collapse without the intermediate step of stellar evolution. This discovery solves one of Webb's most puzzling findings. The telescope has found supermassive black holes throughout the early universe that are far too massive for their age. Traditional black hole formation requires waiting for massive stars to form, evolve, and die in supernova explosions. That process takes hundreds of millions of years, but Webb has found mature supermassive black holes existing just 600 million years after the Big Bang. Direct collapse black holes can reach supermassive status much more quickly because they start with enormous amounts of material. Instead of beginning as stellar mass black holes and growing through accretion, they form with masses potentially millions of times greater than our Sunday. This head start allows them to become the monsters Webb observes in the early universe. The Infinity Galaxy represents a real-time laboratory for studying this exotic formation process. The black hole is actively feeding on gas, flowing between the colliding galactic cores, growing larger as astronomers watch. The system demonstrates that black hole formation can be far more dynamic and rapid than scientists previously imagined. But the direct collapse mechanism raises disturbing questions about cosmic violence during the universe's youth. If such processes were common in the early cosmos, it means galaxy formation was accompanied by catastrophic events that could instantly create some of the most massive objects in the universe. The process also suggests that supermassive black holes might be more fundamental to cosmic structure than previously thought. Instead of forming as byproducts of galaxy evolution, they might be primary drivers of how matter organizes on the largest scales. The Infinity Galaxy's direct collapse black hole proves that the universe has mechanisms for creating massive objects that operate far faster and more violently than conventional models predict. But even this rapid black hole formation couldn't explain the most extreme feeding behavior Webb was about to discover. The telescope's next target would reveal a cosmic monster consuming matter at rates that physics says should be impossible. A black hole in the early universe is devouring matter 40 times faster than the laws of physics allow, and it's growing at impossible rates. Hidden among thousands of X-ray sources in deep space, Jameswebb identified a supermassive black hole that's breaking fundamental rules about how quickly these cosmic monsters can feed. The object, designated LID 568, is consuming matter at 40 times its theoretical limit, a rate so extreme that it challenges our understanding of black hole physics. Every black hole has what scientists call an Eddington limit, the maximum rate at which it can accrete matter without the intense radiation pressure from superheated gases blowing away its food supply. Think of it like trying to drink from a fire hose. Beyond a certain flow rate, the pressure becomes so intense that it prevents further consumption. LID 568 is is somehow drinking from 40 fire hoses simultaneously. The discovery required a combination of Webb's infrared sensitivity and data from NASA's Chandra X-ray Observatory. LID 568 was initially buried among thousands of bright X-ray sources, invisible to optical telescopes, but blazing in high-energy radiation. Webb's unique infrared capabilities allowed astronomers to identify the faint counterpart emissions that revealed the object's true nature. What makes this black hole's feeding frenzy truly disturbing is the implications for its growth rate. At such extreme accretion rates, LID 568 could have gained most of its current mass in a single episode of rapid feeding. The black hole appears to be undergoing what astronomers call a feeding episode, consuming enormous amounts of matter in a relatively brief cosmic timespan. The object exists just 1.5 billion years after the Big Bang, when the universe was still in its infancy. For a black hole to reach supermassive status so quickly, while respecting normal feeding limits, would require starting from impossibly large seed masses. LID 568's extreme feeding rate provides a potential solution to this cosmic timing problem. The speed and size of material flowing away from the black hole suggests that substantial portions of its mass growth occurred during similar feeding frenzies. These are not gradual accretion processes spread over billions of years, but violent consumption events that can increase a black hole's mass by enormous factors in cosmic eye blinks. The physics of such extreme feeding remains poorly understood. The black hole is somehow stabilizing the accretion process, despite radiation pressures that should blow away its food supply. Either the black hole has developed some mechanism for controlling radiation pressure, or the surrounding matter has properties that allow it to resist being blown away. LID 568 represents the extreme end of black hole feeding behavior, operating under conditions that push physics to its breaking point. The discovery suggests that the early universe hosted feeding events far more violent and rapid than anything seen in the modern cosmos. These fast-feeding phantoms could explain how supermassive black holes reached their enormous sizes so quickly in cosmic history. Instead of slow, steady growth over billions of years, they underwent brief but intense feeding episodes that increased their masses by factors of 10 or more. But LID 568's impossible feeding rate was just one example of the bizarre behavior Webb was finding throughout the early universe. The telescope's surveys were revealing that the cosmos's youth was far more chaotic and violent than anyone had imagined. Massive galaxies are sitting dead and silent in regions of space where they should be blazing with star formation, and astronomers can't explain why they stopped growing. Jameswebb has discovered what researchers are calling sleeping beauty galaxies, scattered throughout the early universe, massive star systems that mysteriously shut down their star formation processes when they should have been in their most active phase. These cosmic giants contain billions of stars but show no signs of creating new ones, defying every model of how galaxies evolved during their youth. The discovery emerged when astronomers examined galaxies that formed between 600 million and 6 billion years after the Big Bang. During this period, the universe was rich with gas and dark matter, creating ideal conditions for rapid star formation. Most galaxies from this era should be blazing with the light of newly formed stars, consuming available gas at furious rates to build their stellar populations. Instead, Webb found numerous massive galaxies that appear to have fallen into cosmic hibernation. These systems contain stellar masses comparable to our Milky Way, but show none of the vigorous star formation expected from young galaxies. They're like massive cities, where all construction suddenly stopped for no apparent reason. The Sleeping Beauty nickname comes from their dormant state during what should have been their most active period. Like the fairy tale princess who fell into an enchanted sleep, these galaxies stopped growing at the height of their development. But unlike the fairy tale, there's no obvious explanation for what caused their cosmic slumber. Several theories attempt to explain this bizarre behavior, and each one challenges fundamental assumptions about galaxy evolution. The first suggests that supermassive black holes at the centers of these galaxies became so active that their energy output heated surrounding gas to temperatures too hot for star formation. This process, called active galactic nucleus feedback, can shut down star formation across entire galaxies. But the timing doesn't match. The Sleeping Beauty galaxies show signs of having shut down their star formation before their central black holes became active enough to cause such widespread heating. Something else must have triggered their dormancy. A second theory proposes that these galaxies consumed their gas supplies so rapidly during an initial burst of star formation that they literally ran out of fuel. This explanation requires star formation rates far higher than current models predict, suggesting that early galaxies could build stars much more efficiently than modern systems. The most disturbing possibility is that the Sleeping Beauty galaxies encountered some unknown process that doesn't exist in the modern universe. The early cosmos operated under different physical conditions, with higher matter densities and different dark matter distributions. Perhaps these conditions allowed for star formation shutdown mechanisms that we've never observed. The existence of dormant galaxies in the early universe has profound implications for our understanding of cosmic evolution. If massive galaxies could shut down their growth processes so early in cosmic history, it suggests that galaxy formation is far more complex and unpredictable than scientists previously believed. These cosmic sleeping beauties represent another piece of evidence that the early universe was a far stranger and more violent place than our models predict. A rogue planet drifting through space has developed the most bizarre atmosphere ever discovered, with separate cloud layers made of iron and magnesium minerals. SIMP 0136 plus 0933 is unlike any world in our solar system. This cosmic wanderer doesn't orbit a star, but instead drifts freely through the galaxy, illuminated only by the faint glow of its own internal heat. Jameswebb's detailed atmospheric analysis revealed something unprecedented. This rogue planet has a layered atmosphere where iron rain falls through clouds made of magnesium minerals. The planet's atmosphere resembles a cosmic layer cake, with different types of metallic clouds stacked at various altitudes. Near the surface, a dense layer of iron clouds creates weather patterns unlike anything on Earth. These aren't wisps of water vapor, but thick concentrations of vaporized metal that condense and fall as liquid iron rain during the planet's storm. Higher in the atmosphere, a second cloud layer composed of forsterite, a magnesium-rich mineral commonly found in meteorites, creates an entirely different weather system. These silicate clouds form when temperatures and pressures reach exactly the right conditions for magnesium compounds to vaporize and condense. The interaction between these two cloud layers creates atmospheric dynamics that push the boundaries of planetary science. Webb's infrared observations revealed that both cloud layers are patchy and constantly changing, suggesting active weather patterns driven by the planet's rotation and internal heat sources. The iron clouds appear to follow different circulation patterns than the magnesium clouds, creating a complex three-dimensional atmospheric structure that varies dramatically across the planet's surface. But the most mysterious aspect of this world's atmosphere comes from high above both cloud layers, where Webb detected what researchers call hotspots. These are regions of intense heat that appear to be powered by radio auroras, electromagnetic phenomena, similar to Earth's northern lights, but operating at energy levels that would be lethal to any known form of life. The radio auroras suggest that SIMP 0136 has an incredibly powerful magnetic field, far stronger than anything in our solar system. This magnetic field interacts with charged particles in interstellar space, creating electrical currents that heat portions of the upper atmosphere to temperatures exceeding those found in the metallic cloud layers below. Alison McCarthy, the graduate student leading the atmospheric analysis, described the planet as having variability mechanisms that had been hypothesized, but never directly observed. The complex interactions between iron clouds, magnesium clouds, and radio auroras create an atmospheric system that operates according to principles we've never encountered before. The existence of such complex atmospheric chemistry on a rogue planet raises disturbing questions about planetary formation and evolution. SIMP 0136 somehow developed and maintained this elaborate atmosphere while drifting through the cold emptiness of interstellar space, far from any stellar energy source. This suggests that rogue planets might be capable of supporting much more complex atmospheric processes than scientists previously imagined. If one wandering world can develop iron rain and magnesium clouds, there could be millions of similar objects throughout the galaxy, each hosting unique atmospheric phenomena that we've never considered possible. The metallic rain world represents a new category of planetary atmosphere that challenges our understanding of what kinds of weather systems can exist in the universe. A bizarre galaxy shaped like a cosmic owl is swimming through deep space, revealing tentacled structures that suggest violent interactions we've never seen before. When Jameswebb captured images of what astronomers playfully nicknamed the cosmic owl, they initially focused on its distinctive appearance. The galaxy's bright central region creates the illusion of two glowing eyes, while surrounding gas and dust formations resemble the feathered outline of an owl's face. But detailed analysis revealed that this cosmic creature is far more alien and disturbing than its whimsical nickname suggests. The cosmic owl belongs to a class of objects called jellyfish galaxies, systems that appear to be swimming through space with long tentacles of gas and stars streaming behind them. These tentacles aren't decorative features, but evidence of violent stripping processes that are tearing the galaxy apart as it moves through its environment. The galaxy is undergoing a process called ram pressure stripping, where its motion through the hot gas-filling galaxy clusters creates a cosmic headwind that literally blows away portions of the galaxy's structure. Imagine driving a convertible at highway speeds while loosely packed cargo flies out of the back seat. The cosmic owl is losing parts of itself as it travels through space. Webb's infrared vision revealed the true extent of this cosmic violence. The galaxy's tentacles stretch for hundreds of thousands of light years, containing billions of stars that have been ripped away from their original homes. These stellar refugees now exist in the tentacles, isolated from the galaxy's main body and slowly dispersing into the void. But the most disturbing aspect of the cosmic owl isn't what it's losing, but what the stripping process reveals about galactic environments. The ram pressure required to create such extensive tentacles indicates that the galaxy is moving through an incredibly dense and hot medium, far more extreme than the relatively empty space between galaxies. This suggests that the cosmic web, the large-scale structure of matter that connects galaxies across the universe, is more violent and turbulent than scientists previously realized. Instead of galaxies moving serenely through empty space, they're fighting their way through environments that can literally tear them apart. The jellyfish process also creates new opportunities for star formation within the tentacles themselves. As gas gets stripped from the galaxy and compressed by ram pressure, it can trigger bursts of star formation in locations far from the galaxy's main body. The cosmic owl is simultaneously being destroyed and creating new stellar populations in its wake. Webb's observations revealed active star formation regions scattered throughout the galaxy's tentacles, glowing bright blue with the light of young massive stars. These stellar nurseries exist in gravitational isolation, billions of light years from the galaxy that originally provided their raw materials. The discovery of extensive jellyfish structures throughout Webb's deep field images suggests that galactic cannibalism and stripping processes are far more common than astronomers previously believed. The universe might be filled with cosmic refugees, stars and gas clouds that have been torn away from their parent galaxies and now drift through the void. The cosmic owl represents just one example of the violence that shapes galactic evolution on the largest scales. But even this galactic destruction pales in comparison to the stellar violence Webb discovered happening within individual star systems. Young stars are creating heavy elements that shouldn't exist yet, forging cosmic chemistry that defies our understanding of stellar evolution. Jameswebb has discovered young star systems producing heavy elements like oxygen, carbon, and nitrogen at levels that should be impossible given their age. These stellar nurseries are creating complex chemistry that, according to every model of stellar evolution, requires billions of years to develop through successive generations of star formation and death. The mystery centers on metallicity, the astronomical term for elements heavier than hydrogen and helium. In the early universe, only these two lightest elements existed in significant quantities. All heavier elements, from carbon and oxygen to iron and gold, had to be forged in the nuclear furnaces of massive stars and dispersed through space when those stars exploded as supernovas. This process should take time. The first generation of stars, called population 3 stars, would have been made almost entirely of hydrogen and helium. When they died, they enriched the surrounding space with newly created heavy elements, allowing the second generation of stars to form with slightly more complex chemistry. This cosmic recycling process continues over billions of years, gradually increasing the metallicity of star-forming regions. Webb has found star systems that appear to have skipped several steps in this process. Young galaxies that formed when the universe was less than 1 billion years old show metallicity levels that should require multiple generations of stellar evolution. They're producing oxygen, carbon, and nitrogen at rates that don't match their apparent age. The most extreme example comes from the galaxy jwst 13.1, observed just 330 million years after the Big Bang. Spectroscopic analysis revealed bright hydrogen emission lines and evidence of heavy element production that suggests the galaxy has already undergone significant stellar evolution, despite existing during cosmic infancy. This impossible chemistry forces scientists to reconsider fundamental assumptions about early star formation. Either the first generation of stars was far more massive and short-lived than current models predict, allowing them to create and disperse heavy elements much more rapidly, or some entirely unknown process was enriching the early universe with complex chemistry. The first possibility suggests that population 3 stars were cosmic monsters, perhaps hundreds of times more massive than our Sunday. These stellar giants would have burned through their nuclear fuel in just a few million years before exploding in hypernovas that scattered heavy elements across vast regions of space. Such massive stars don't exist in the modern universe, but the extreme conditions of the early cosmos might have allowed their formation. The second possibility is even more disturbing. If unknown processes were creating heavy elements in the early universe, it means our understanding of cosmic chemical evolution is fundamentally incomplete. Some mechanism beyond stellar nucleosynthesis might have been operating during the universe's youth, creating complex chemistry through pathways we've never identified. The rapid metallicity evolution Webb has observed also affects our understanding of planet formation and the potential for early life. If heavy elements became available much sooner than previously thought, rocky planets and the chemical building blocks for life might have emerged far earlier in cosmic history. These discoveries suggest that the early universe was capable of chemical complexity that makes our models look like oversimplified approximations of reality. A world orbiting our nearest stellar neighbor keeps appearing and disappearing in Webb's observations, and astronomers can't figure out why it exists at all. In what researchers are calling the most significant Jameswebb finding to date, the telescope detected a giant planet orbiting Alpha Centauri A, our closest sun-like star, only to lose track of it completely during follow-up observations. This cosmic vanishing act has created one of the most baffling mysteries in exoplanet science. The planet, tentatively designated Alpha Centauri AB, appeared in Webb's initial observations as a thermal signature, consistent with a world roughly the size of Neptune, orbiting within the habitable zone of Alpha Centauri A. The discovery would have been groundbreaking enough on its own, representing the closest potentially habitable planet to Earth ever found. But when astronomers attempted to confirm the detection with additional observations, the planet simply wasn't there. Subsequent imaging sessions showed no trace of the thermal signature that had been so clear in the original data. The planet had either moved to a position where Webb couldn't detect it, or it had somehow ceased to exist entirely. Several explanations have been proposed for this cosmic disappearing act, and each one challenges conventional understanding of planetary systems. The first suggests that the planet has an extremely elliptical orbit that carries it far from its star for most of its year, making it detectable only during brief periods when it passes close enough to emit significant thermal radiation. But orbital mechanics makes this explanation problematic. A planet with such an extreme orbit around Alpha Centauri A would be gravitationally unstable, likely ejected from the system by interactions with the star's binary companion, Alpha Centauri B. The gravitational dance between two stars creates complex dynamics that make stable planetary orbits difficult to maintain. The second explanation is even more unsettling. The planet might be real, but surrounded by a variable dust cloud or debris ring that periodically obscures it from Webb's infrared sensors. This would suggest that the Alpha Centauri system is far more dynamically active than previously believed, with ongoing collisions or disruptions creating temporary veils around orbiting worlds. A third possibility challenges our understanding of planetary formation entirely. The thermal signature might represent a world that's still forming, accreting material from a protoplanetary disk in episodes that make it alternatively visible and invisible to infrared observation. This would mean that planet formation is still actively occurring in the Alpha Centauri system, despite the stars being billions of years old. The most disturbing explanation is that Webb detected something that isn't a planet at all. The thermal signature might represent a previously unknown type of cosmic phenomenon, perhaps a dense cloud of warm debris, or even a failed star formation event occurring in the outer regions of the Alpha Centauri system. The vanishing planet mystery highlights how much we still don't know about planetary systems, even ones in our immediate cosmic neighborhood. If a world can appear and disappear in observations of our nearest stellar neighbor, it raises questions about what other planetary phenomena might be hiding in plain sight. The Alpha Centauri vanishing act serves as a reminder that space remains full of surprises that challenge our most basic assumptions about how planetary systems work. Ancient magnetic fields discovered throughout the cosmic web are as complex as human brain networks, and they're older than any known structure in the universe. Jameswebb has detected evidence of magnetic fields stretching across the largest structures in the cosmos, creating patterns of connectivity that eerily resemble the neural networks found in human brains. These primordial magnetic fields appear to be remnants from the universe's first billion years, when cosmic structure was still forming through processes we barely understand. The discovery emerged from Webb's observations of the cosmic web, the vast network of filaments and voids that organizes matter on the largest scales. Between galaxies and galaxy clusters, thin streams of gas and dark matter create bridges spanning hundreds of millions of light years. Webb found that these cosmic filaments are threaded with magnetic fields of extraordinary complexity. The magnetic field patterns show a level of organization that shouldn't exist in the early universe. Instead of simple, uniform fields, Webb detected intricate networks with nodes, connections, and hierarchical structures that mirror the topology of biological neural networks. The similarity is so striking that researchers are using the same mathematical tools developed to study brain connectivity to analyze cosmic magnetism. These ancient magnetic fields raise fundamental questions about cosmic evolution. Standard models assume that magnetic fields in space develop gradually as galaxies and stars form, with stellar winds and supernova explosions creating and amplifying magnetic structures over billions of years. The primordial fields Webb discovered appear to predate this process entirely. The fields show evidence of having influenced early galaxy formation in ways that current theories don't account for. Magnetic pressure and magnetic reconnection events might have shaped how gas collapsed into the first stars, affecting stellar masses, formation rates, and the chemical evolution of early galaxies. Perhaps most disturbing is what these magnetic networks suggest about the nature of cosmic structure formation. The brain-like patterns indicate that the universe developed organizational complexity far earlier than scientists believed possible. Instead of simple gravitational collapse creating cosmic structure, the early cosmos might have operated more like a vast information processing system. The magnetic field networks also appear to be dynamic, with connections forming and breaking across cosmic time. Webb detected evidence of magnetic storms spanning entire galaxy clusters, events that could affect star formation and galactic evolution across vast regions of space. The discovery has implications for our understanding of dark matter and dark energy. Magnetic fields can interact with charged particles in ways that affect how matter clumps together on large scales. If primordial magnetism was more complex and powerful than current models assume, it might explain some of the discrepancies Webb has found in cosmic structure formation. The brain-like magnetic networks represent a fundamental challenge to our understanding of how complexity emerges in the universe. If such sophisticated organizational structures existed in the cosmic web's youth, it suggests that the universe has intrinsic tendencies toward complexity that we've never recognized. These primordial magnetic fields might be evidence that the universe itself has properties analogous to living systems, with information processing and organizational capabilities that emerge from physical processes we don't yet understand. A supermassive black hole at the center of our galaxy is pulsing with irregular rhythms that suggest unknown physics operating at the edge of spacetime. Sagittarius A star, the 4 million solar mass black hole at the Milky Way's center, has been quietly surprising astronomers for decades. But Jameswebb's continuous monitoring revealed something unprecedented. The cosmic monster exhibits erratic brightness fluctuations that resemble a heartbeat with no discernible pattern. Using Webb's near-infrared camera, researchers observed Sagittarius A star for 48 hours, spread across multiple sessions throughout 1 year. What they discovered was a black hole in constant flux, with its accretion disk producing a continuous but chaotic series of brightness changes, punctuated by sudden, dramatic flares. The observations showed constantly changing, bubbling brightness across the black hole's event horizon region. Then, without warning, massive bursts of radiation would suddenly erupt from the accretion disk before calming down again. These flares appear completely random, defying every attempt to find underlying patterns or periodicities. Farhad Yousefzadeh, the Northwestern University professor leading the research, described the behavior as unlike anything previously observed in supermassive black holes. The team found no patterns in the activity, suggesting that the processes driving these brightness changes operate according to physics that current models don't fully capture. Two mechanisms appear to be creating this cosmic heartbeat. Short-term fluctuations likely result from turbulence within the accretion disk, where magnetic field interactions compress plasma and create temporary flashes of radiation. Think of it as cosmic lightning occurring in the superheated gas spiraling toward the black hole's event horizon. But the larger flares suggest something more dramatic. These massive brightness increases might result from entire chunks of matter crossing the black hole's photon sphere, the region where light itself begins to orbit the black hole before either escaping or falling past the event horizon forever. The irregular nature of these events indicates that Sagittarius A star is more active than astronomers previously realized. Instead of the relatively quiet, slowly feeding monster described in textbooks, The Milky Way's central black hole appears to be in a constant state of low-level violence, consuming matter in unpredictable episodes. What makes this behavior truly disturbing is its implications for black hole physics near the event horizon. The brightness fluctuations originate from regions where space and time are severely distorted by gravity, creating conditions where matter and energy behave according to principles that push general relativity to its limits. The chaotic nature of the brightness changes suggests that quantum effects might be playing a role in black hole accretion processes. Near the event horizon, the boundary between classical and quantum physics becomes blurred, potentially creating phenomena that don't exist anywhere else in the universe. The heartbeat pattern also raises questions about what happens to information that falls into black holes. If the accretion disk's behavior is truly random, it might indicate that black holes destroy information in ways that violate fundamental principles of quantum mechanics. Sagittarius A star's irregular pulsing represents our closest look at physics. Operating under the most extreme conditions the universe can create, where gravity becomes so strong that space and time themselves begin to break down. Invisible forces are reshaping cosmic structure through violent processes that leave galaxies shredded and scattered across millions of light years. Jameswebb has uncovered evidence that dark matter, the mysterious substance comprising 85% of all matter in the universe, participates in violent interactions that can tear apart entire galaxies and reshape cosmic structure on the largest scales. These dark matter catastrophes operate through mechanisms that remain completely invisible except for their devastating effects on normal matter. The evidence comes from Webb's observations of galaxy clusters, regions where hundreds of galaxies are held together by the gravitational influence of massive dark matter concentrations. When these cosmic cities collide, they create some of the most energetic events in the universe, releasing energies comparable to billions of supernova explosions. But Webb's detailed imaging revealed that the violence extends far beyond the visible collision zones. Galaxies located millions of light years from cluster collisions show signs of having been violently disrupted by gravitational forces that can only be explained by dark matter interactions operating on previously unimaginable scales. The telescope detected extensive streams of stars and gas connecting galaxies across vast distances, creating bridge-like structures that span the space between separate galactic systems. These stellar streams represent the torn remnants of galaxies that have been gravitationally shredded by dark matter forces during cluster interactions. What makes this cosmic violence particularly disturbing is its hidden nature. While normal matter interactions create visible fireworks through electromagnetic radiation, dark matter collisions produce no light, no heat, and no electromagnetic signatures. The only evidence of these catastrophic events comes from their gravitational effects on the matter we can see. Webb's infrared sensitivity has revealed the full extent of this dark violence. Faint stellar streams and tidal tails extend for millions of light years around galaxy clusters, creating vast spiderwebs of disrupted matter that previous telescopes were too insensitive to detect. Each stream represents a galaxy that has been partially or completely destroyed by dark matter interactions. The scale of this destruction suggests that dark matter doesn't simply provide passive gravitational scaffolding for cosmic structure. Instead, it participates actively in reshaping the universe through violent processes that can eject galaxies from their host clusters, strip away their gas supplies, and scatter their stars across intergalactic space. Computer simulations of dark matter interactions show that these violent events might be fundamental to cosmic evolution. Dark matter particles can undergo collisions and gravitational interactions that create shock waves propagating through the cosmic web, affecting galaxy formation across vast regions of space. Perhaps most unsettling is what this hidden violence suggests about the nature of dark matter itself. If dark matter can participate in such energetic interactions, it might have properties beyond simple gravitational attraction. Some models propose that dark matter particles can undergo phase transitions or interact through forces that we haven't yet identified. The discovery of widespread dark matter violence also affects our understanding of galaxy evolution and the formation of cosmic structure. If galaxies are constantly being disrupted and reformed through dark matter interactions, the universe might be far more dynamic and chaotic than our models predict. These invisible catastrophes represent a fundamental aspect of cosmic evolution that operates completely outside our direct observation, shaping the universe through violence we can only detect through its aftermath. A distant galaxy is bending spacetime so severely that it appears in multiple locations simultaneously, creating gravitational effects that challenge our understanding of general relativity. Jameswebb discovered a galaxy so massive and dense that its gravitational field creates multiple images of itself across the cosmic sky, each showing the same star system at different points in its evolution. This extreme gravitational lensing effect demonstrates space-time curvature operating at levels that push Einstein's general relativity to its theoretical limits. The phenomenon, called strong gravitational lensing, occurs when an object becomes so massive that its gravity bends the fabric of space-time like a cosmic magnifying glass. Light from more distant objects follows these curved paths, creating distorted or multiple images that can appear in surprising locations across the sky. But this particular galaxy creates lensing effects far more extreme than anything previously observed. Webb detected at least 4 separate images of the same background galaxy, each magnified by different amounts and showing the star system at different epochs in its history. The gravitational field is so powerful that light takes different amounts of time to travel along each curved path. This time delay effect means that astronomers are essentially watching the same galaxy's history unfold in multiple versions simultaneously. One image shows the galaxy as it appeared 800 million years ago, while another reveals its structure 1 billion years in the past. The lensing galaxy has created a cosmic time machine that displays stellar evolution across multiple epochs. What makes this discovery truly disturbing is the implied mass distribution of the lensing galaxy. To create such extreme space-time curvature, the galaxy must contain dark matter concentrations far denser than current models predict. The dark matter appears to be clumped into structures that challenge our understanding of how these mysterious particles interact and organize themselves. The lensing effects also reveal substructure within the dark matter distribution that shouldn't exist according to standard cosmological models. Instead of smooth dark matter halos surrounding the galaxy, Webb detected evidence of dark matter clumps and voids that suggest complex internal dynamics operating through unknown mechanisms. The time delay measurements between different lensed images provide direct observational evidence of space-time curvature operating according to general relativity's predictions. But the extreme nature of the lensing pushes these effects into regimes where quantum gravitational effects might begin to influence classical space-time geometry. Perhaps most unsettling is what this discovery suggests about the prevalence of such extreme gravitational environments in the universe. If one galaxy can create space-time curvature this severe, there might be numerous other cosmic regions where space and time are distorted beyond our current ability to model or understand. The multiple images also reveal that the lensed galaxy itself is undergoing rapid evolution, with star formation rates changing dramatically between the different time epochs visible in each image. This provides unprecedented insights into how galaxies evolve during their most active phases. The time warp galaxy represents a natural laboratory for studying general relativity under extreme conditions, revealing how massive objects can literally reshape the geometry of space and time around them. These gravitational effects operate on scales where classical physics begins to break down, potentially revealing new aspects of cosmic structure that exist at the boundary between general relativity and quantum mechanics. Stars throughout the universe are devouring their companions in feeding frenzies so violent they create entirely new types of cosmic explosions. James Webb has captured direct evidence of stellar cannibalism occurring throughout the cosmos, revealing that binary star systems often end in catastrophic episodes where one star literally consumes its companion. These cosmic feeding events create some of the most violent explosions in the universe, generating energies that can outshine entire galaxies. The process begins when two stars orbit each other closely enough that their outer atmospheres begin to interact. The more massive star gradually strips material from its companion, creating streams of superheated gas that spiral inward in brilliant accretion disks. What starts as a gradual feeding process can suddenly accelerate into a catastrophic consumption event. Webb's infrared vision has revealed these stellar feeding frenzies in unprecedented detail. The telescope can peer through the gas and dust that normally obscures such violent events, showing how matter streams from victim stars to their companions in complex gravitational dances that end in cosmic cannibalism. The most extreme cases involve white dwarf stars, the dense remnants of dead stars, roughly the size of Earth, but containing the mass of our Sunday. When these cosmic vampires accrete material from companion stars, they can trigger thermonuclear explosions called Type Ia supernovas that temporarily outshine billions of normal stars. But Webb has discovered even more violent stellar cannibalism events involving neutron stars and black holes. When these ultra-dense objects consume companion stars, they create kilonova explosions that forge heavy elements like gold and platinum, while releasing gamma-ray bursts that can be detected across billions of light years. The telescope has documented the complete life cycle of stellar cannibalism, from the initial stages where companion stars begin losing material, through the rapid accretion phases where feeding accelerates dramatically, to the final explosive events that scatter heavy elements throughout space. Perhaps most disturbing is how common these cosmic feeding events appear to be. Webb's surveys suggest that stellar cannibalism might be a fundamental driver of chemical evolution in the universe, responsible for creating and distributing many of the heavy elements essential for planet formation and potentially life. The violent nature of these events also affects surrounding stellar nurseries. Stellar cannibalism explosions can trigger or halt star formation across vast regions, creating feedback effects that influence galactic evolution on scales much larger than the original binary systems. Webb has also discovered evidence of failed cannibalism events, where binary systems begin the feeding process but get disrupted before reaching explosive conclusions. These cosmic near-misses create exotic stellar remnants with properties unlike any objects in our local galactic neighborhood. The prevalence of stellar cannibalism forces astronomers to reconsider how binary star evolution affects cosmic chemical evolution. Instead of stars living isolated lives and dying peaceful deaths, many participate in violent feeding relationships that end in catastrophic explosions. These cosmic feeding frenzies represent one of the primary mechanisms through which the universe creates and distributes the heavy elements necessary for complex chemistry and potentially life itself. Evidence is mounting that reality itself breaks down at cosmic scales, revealing fundamental cracks in the fabric of spacetime that challenge our most basic understanding of physics. James Webb's most disturbing discovery might not be any single object, but rather the accumulating evidence that spacetime itself becomes unstable under extreme conditions found throughout the cosmos. The telescope has detected gravitational anomalies, unexplained energy signatures, and structural irregularities that suggest the smooth fabric of spacetime, described by general relativity, is more fragile than anyone imagined. The evidence comes from multiple sources across Webb surveys. Gravitational lensing effects around some massive objects don't follow precise general relativistic predictions, showing small but persistent deviations that could indicate spacetime structure breaking down under extreme gravitational stress. These anomalies appear near black holes, in galaxy cluster cores, and around other massive cosmic structures. Quantum mechanics predicts that spacetime at the smallest scales should be foamy and chaotic, with virtual particles and energy fluctuations creating a turbulent quantum foam that underlies smooth classical geometry. But Webb's observations suggest that this quantum foam might bubble up to macroscopic scales under certain extreme conditions. The telescope has detected unexplained energy emissions from regions where quantum effects shouldn't be observable, including mysterious radiation signatures from black hole event horizons and anomalous heating in galaxy cluster cores. These phenomena might represent quantum foam breaching into classical spacetime during particularly violent cosmic events. Perhaps most unsettling are Webb's observations of what astronomers call cosmic strings, hypothetical, one-dimensional defects in spacetime that could have formed during the universe's earliest moments. If these structures exist, they represent fundamental cracks in reality itself, places where spacetime is literally torn or folded in ways that violate our understanding of cosmic geometry. The telescope has identified several candidates for cosmic string signatures, including gravitational lensing patterns that can't be explained by any known distribution of matter or energy. These observations suggest that the universe might contain permanent scars from its violent birth, defects that persist as vulnerabilities in space-time structure. Webb has also found evidence of vacuum decay events, regions where the quantum vacuum appears to have transitioned to lower energy states through processes that release enormous amounts of energy. These events could represent fundamental phase transitions in the structure of reality itself. The accumulating evidence suggests that the universe operates closer to the edge of physical stability than previously believed. Under extreme conditions involving massive gravitational fields, high energy densities, or exotic matter states, the fundamental structure of spacetime might become unstable. These quantum foam breaches have profound implications for our understanding of cosmic evolution and the ultimate fate of the universe. If spacetime can become unstable under conditions that exist naturally in the cosmos, it raises questions about whether reality itself might be more temporary and fragile than we assume. The discovery of quantum effects operating on cosmic scales also suggests that the boundary between quantum mechanics and general relativity might be more porous than theoretical physics predicts, with implications for our understanding of black holes, cosmology, and the fundamental nature of reality. The coordinated rotation of galaxies and the strange behavior of cosmic expansion suggest we might be living inside a black hole within a larger universe. The most terrifying possibility raised by Jameswebb's discoveries is that our entire observable universe might be the interior of a massive black hole existing within a larger cosmic structure. This black hole cosmology theory explains several of Webb's most puzzling observations, including the coordinated galaxy rotations and the impossible expansion rate contradictions that have shattered conventional cosmology. The evidence begins with the galaxy rotation patterns Webb discovered during its deep surveys. Galaxies separated by millions of light years are spinning in coordinated directions, a phenomenon that should be impossible unless the entire universe has a preferred rotational axis. In black hole cosmology, this coordination would result from our universe inheriting the angular momentum of the parent black hole that contains us. The theory suggests that what we call the Big Bang was actually our universe crossing the event horizon of a massive black hole in a higher dimensional space. From our perspective inside the black hole, this crossing appears as cosmic expansion, but from the perspective of the larger universe, we're falling toward the black hole's singularity in a process that will take infinite time due to gravitational time dilation. This scenario explains the accelerating expansion of space that we attribute to dark energy. As we fall deeper into the parent black hole, spacetime curvature increases, creating the illusion that expansion is accelerating when we're actually approaching regions of more severe gravitational distortion. Webb's discovery of primordial black holes that predate star formation also fits the black hole cosmology model. These ancient monsters could be smaller black holes that existed in the parent universe before we crossed the event horizon, appearing in our cosmic history as primordial objects that formed before normal matter could collapse into stars. The coordinated galaxy spins that Webb observed across vast regions of space make perfect sense if our universe inherited rotational momentum from a spinning parent black hole. The galaxies aren't mysteriously coordinating their motion. They're all participating in the same cosmic rotation that was imprinted on spacetime when our universe formed. Even the expansion rate contradictions that have puzzled astronomers fit the black hole cosmology model. Different measurement techniques might be detecting different aspects of our motion through the curved spacetime inside the parent black hole, creating apparent contradictions that result from viewing the same phenomenon from multiple perspectives. If black hole cosmology is correct, it means that everything we can observe, from the cosmic microwave background to the most distant galaxies, exists within the event horizon of an incomprehensibly massive black hole. We would be forever separated from the larger universe that contains us, unable to communicate with or affect anything outside our cosmic prison. The theory also suggests that black holes throughout our universe might contain entire universes of their own, creating a nested hierarchy of cosmic structures where each black hole serves as a gateway to a complete cosmic realm with its own physics, evolution, and potentially life. This possibility transforms our understanding of cosmic significance and our place in the broader structure of reality, suggesting that what we call the universe might be just one bubble in an infinite multiverse of black hole universes. The discoveries Jameswebb has made don't just challenge our understanding of the cosmos, they fundamentally alter what it means to be human in a universe far stranger and more dangerous than we ever imagined. Every assumption we've made about our cosmic environment has been shattered by Webb's revelations. We thought we understood how galaxies form, how black holes grow, and how the universe expands. Instead, we've discovered that space is filled with impossible objects, violent processes, and phenomena that operate according to physics we don't comprehend. The universe Webb reveals is not the orderly, predictable cosmos described in textbooks. It's a realm where galaxies can form faster than physics allows, where black holes wander naked through space, and where the very fabric of space-time might be unstable. We're not living in a cosmic garden designed for life, but in a violent arena where reality itself can break down under extreme conditions. Perhaps most unsettling is what these discoveries suggest about our cosmic isolation. If we're living inside a black hole universe, as the evidence increasingly suggests, then we're forever cut off from whatever larger reality contains us. Every signal we send, every exploration we attempt, will remain trapped within our cosmic prison. The prevalence of cosmic violence that Webb has revealed also affects our long-term survival prospects. The universe is filled with wandering black holes, rogue planets broadcasting mysterious signals, and stellar cannibalism events that can sterilize entire regions of space. Our galactic neighborhood might be far more dangerous than we realized. The rapid pace of discovery has also revealed how little we actually know about the cosmos we inhabit. Despite centuries of astronomical progress, Webb's first few years of operation have uncovered phenomena that require completely rewriting our understanding of cosmic evolution. If we've been this wrong about fundamental cosmic processes, what else have we missed? The telescope's discoveries about early galaxy formation and primordial black holes suggest that the universe achieved complexity far earlier than we believed possible. This means that cosmic evolution might follow pathways we've never considered, potentially including the development of intelligence and civilization on timescales and in environments we've never imagined. But Webb's revelations also offer hope. The universe's capacity for surprise and complexity suggests that cosmic evolution might be far richer and more diverse than our models predict. If reality can produce impossible galaxies and naked black holes, it might also be capable of creating forms of life and intelligence that operate according to principles we haven't discovered. The telescope has essentially revealed that we're cosmic infants, living in a universe that operates according to rules we're only beginning to glimpse. Every strange object Webb discovers, every impossible phenomenon it reveals, represents an opportunity to expand our understanding of what's possible in a cosmos that clearly delights in violating our expectations. Perhaps, most importantly, Webb's discoveries remind us that the universe doesn't owe us comprehensibility. Reality operates according to its own logic, following principles that might be fundamentally alien to human intuition. Our survival and success as a species depends on our ability to adapt our understanding to match the cosmos as it actually exists, rather than as we wish it were. The universe James Webb has revealed is strange, violent, and often incomprehensible, but it's also the only reality we have, and understanding it, no matter how disturbing that understanding might be, represents our best hope for navigating the cosmic future that awaits us.